Hello, everyone. We are Urban Intelligence. My name is Chris Walker.
I'm Alyssa Wilson.
I'm Bear Ergo.
My name is Hannah Gooden.
I'm Amy Idiozu.
I'm Wanyu Liu.
I'm John Garza.
I'm Megan Fletcher.
Augustine Salazar.
Clint McClellan.
So Urban Intelligence is a dynamic team of a number of Texas A&M undergrads, and we are working together to develop technology and technology-driven solutions for the city of Nolanville in Texas. Like I said, our team is comprised of multiple students, 10 students across 5 majors, and we have 3 distinct yet intertwined project goals with landscape architecture and civil engineering working on greenscapes, streetscapes, phasing plans, things of that nature. Urban planning also helping out with some of that, rendering support, a proposal packet, and then finally electrical engineering and computer science working together to develop a functioning train sensor model that helps identify whenever an oncoming train is coming to the city of Nolanville. So with this team, we have a wide range of skill sets, and we're creating proposals that are actionable and directed specifically to help the city of Nolanville become known as a smart city across the state of Texas and across the country.
So our problem statement is, as Urban Intelligence, we want to provide a proposal for the city to implement revitalized green spaces, promote community engagement, communication, connectivity, and mobility throughout the area. And so this is our master plan that shows everything working together. So we have our greenway, the commercial corridor, the streetscape development, the smart garden, and the community center green roof. And then we also have 2 train sensor notification locations.
The project that the computer science and electrical engineering students have been working on is the Smart Train Notification System. The system was designed with the intent of solving the problem of the unpredictable train schedule and making the information collected accessible to all citizens of Nolanville, regardless of their socioeconomic standing. Understanding that not all citizens of Nolanville have reliable access to a smartphone or computer, we decided to focus mainly on creating a traffic signal that would notify residents of incoming trains instead of a website or mobile app.
So the system we're using for train recognition consists of 2 Raspberry Pis, which are very low-powered small computers that we can place pretty much anywhere. The first one will be connected to a camera that will be looking down the tracks for trains coming. On the Pi, we'll be running a code to notice if any trains are coming. If it detects a train, it'll wirelessly send the signal to the second Raspberry Pi, which will be connected to a light or some sort of signal. They'll notify the residents.
So us computer science students have been working on a machine learning algorithm that we can use to detect whether a train is approaching on the tracks. And so the algorithm we chose to use is a neural net using a few pre-trained layers, which are available publicly on the internet. The training data, which we have been using to develop this algorithm, was collected here in College Station. We took over 500 images ourselves in 2 different sittings. So these images represent 2 separate intersections where trains cross, 2 different kinds of weather, 2 camera orientations, and lots and lots of angles. And so the goal with that is to get as many different situations as we can where a train could be approaching, so that our algorithm will be more accurate and more scalable, because we couldn't go and take pictures at Nolanville. So by getting as many different possible situations in College Station as we could and collecting images from those, we were able to get a very diverse training data set, so that when our algorithm is deployed in Nolanville, it will still be able to work. So using this training data and the algorithm that we developed, we are able to currently get a 99% accuracy on the test data. So
We implement solar panel technology in both smart train notification system and green space light. The benefit of using solar panel technologies are it is renewable energy, so it is environmental friendly, and it can reduce electricity bill. To store energy for night and cloudy days where there's not enough sunlight, we will use solar panel power bank. After power consumption calculation, the power bank we decide to used for smart train notification system is the one with 48 amp hour. With fully charged 48 amp hour power bank, this power bank can provide smart train notification system to run at least 1.5 days without any sunlight charging. The cost estimation for hardwares are listed in the table. As you can see, the hardware cost for smart train notification system is about $228, and the hardware cost for green roof depends on how many LED lights are needed for the green roof. The solar panel LED lights cost about $7 each.
Moving on to the green roof section of our proposal. What separates our green roof design from the average design that you see is that we plan on reaping multiple benefits from our green roof that will be useful to the city. For instance, we view the green roof as the ideal location to disguise sensors that can collect useful information that can be processed by our computer scientists. By doing this, we will be able to provide flooding, noise, and ecosystem solutions without causing visual headaches to residents. All of this on top of the benefits that come naturally with any green roof. So there's a lot of information that needs to be gathered to see if Nolanville has retrofitting potential, which means if we could just put the green roofs on existing buildings already. This would prove very valuable to the city, specifically in the energy savings sector, because on newly implemented buildings, there's already enough insulation to where a green roof does not cause that much of a difference in savings. The benefits shown are expected with any green roof. The main two we as a team decided would be of the biggest impact in Nolanville is the stormwater mitigation potential and its contribution to the smart city aesthetic of Nolanville. As it pertains to maintenance, the cheaper green roof modules that we plan on implementing don't require much maintenance, so you wouldn't have to see much cost in that sector. We believe that a green roof can provide the city with a platform to attract new residents, businesses, and investors by creating a visual space of contemporary growth and innovation. A cost-benefit analysis for a green roof is highly location-dependent. Useful information provided by the city of Nolanville would include energy use statistics, intensive flood data, and structural information for each building. Although the likelihood is that it would take years for a green roof to pay itself off, if the city shows businesses and investors it is taking the next step of growth, the benefits could be invaluable to the city. We did a case study on a building in Nolanville. We chose the community center because we viewed the community center as a hub to the community where people can come together and feel inspired. On top of this, it is also adjacent to a major flooding area of town, as shown by the red dot in the map to the right. The blue region of this map shows the surge from a 10-year flood event. In this frequently occurring event, you would see water retention up to 66.7 gallons a minute, which could prove invaluable to flooding in that area of the city. Although we would need more data on the culvert that's adjacent to this building to know if it would truly make a difference. As it pertains to energy savings, there would most likely not be much energy savings at the community center because of the insulation that's already most likely in it.
Our main implementation, as far as the street level goes, are bike lanes and sidewalks in areas that we have found that they will be most appropriately used. The section here is a cut of Main Street located on the east side of the commercial corridor. This section is different because it includes a bioswale for the water in the corridor to drain to. The bioswale will help with the water drainage from the pedestrian area, as well as bring more green space aspects to the sidewalk. The section is a cut of a basic street design proposed for the rest of the area. This section shows a 5-foot bike lane on either side of the street and a 10-foot sidewalk on either side as well. We feel that bike lanes would be beneficial in the downtown area, as well as sidewalks, because they will make the area more inviting for people and visitors to enjoy and increase the walkability aspect in the area. We also chose to implement LID materials for our streetscapes and proposals. LID refers to low impact development, which means the use of systems that natural processes, infiltration, or natural stormwater management practices that protect water quality and the natural habitat. We plan on using permeable pavement, bioswales, and rainwater harvesting, which is on the green roof designed by our engineers.
As Augustine was saying, with low impact stuff, given Nolanville deals with frequent flooding issues, any sort of implementation of low impact green infrastructure could be very valuable to the city. Not only is it valuable technically in retaining water, but it also provides the city with the aesthetic of growth and prosperity that we're shooting for as a team.
So for the retail corridor for Nolanville, it would be in the downtown area right off of Main Street and Avenue H. I based this off of some examples that I've seen throughout our region and even to other states, where it's a pedestrian-oriented corridor, about as wide as a street, but with no vehicular traffic. And it focuses just on pedestrian implementations, like night lighting, shade trees, planter beds, and a variety of benches and seating. And then in the retail buildings, we would plan for that to be mainly commercial retail and dining, with the dining emphasis on outdoor seating, to bring people into that pedestrian corridor. And so here you see a little bit of a net operating income estimation. And so this is based off of Austin, Texas. For the construction cost, you can see we have about 35,000 square feet of buildings and 15,000 of paving. And so that cost is going to run you around $3 million. And this is looking at it from a developer standpoint. So as far as going into an in-depth look at the finances, that would be up to the developer, but this can show the city a little bit about what revenue it would generate. So you have $3 million for the cost. And then for the potential income, I based the price per square foot from tenants based off Austin. It's $25 per square foot. And I drew that out for 5 years. And you can see over 5 years, minus some operating expenses, you have just over $4 million, while those construction costs still sit at around $3.25 million. And so it's definitely feasible from a developer standpoint, and would also bring in a lot of revenue for the city as far as the taxes for the land. And then here you just see a in-depth look at the perspective of the pedestrian walkway in the retail corridor. And so the things I spoke about, the outdoor dining, you can see here, shade structures, trees, night lighting. So it's just really inviting and allows places for social gatherings and an increase in sense of community for Nolanville.
Another proposal that we feel would really connect the community and define the area is a community garden located off of Main Street and next to the food pantry. This area is also equipped for food trucks and a potential farmers market area. We initially started with this idea because we wanted something that would bring the community together as well as be a project area. This garden would be equipped for students, parents, community members to engage in, and we plan on using smart technology throughout this area as well. Here's just a perspective of what the area would roughly look like with raised planters, and it would be a place for people to grow vegetables and kind of just engage in activity. And that's why we mentioned that it could also be a farmer's market area for kids to go and learn about that end as well. 3 main uses of smart technology in our proposals are smart powered irrigation systems, solar paneled lighting, as well as solar paneled paving. Each of these provide a way of easy access to system structure and then a more economically friendly design, an area for economical growth and overall an updated featured design.
This greenway is also another proposal. It's an area of environmental involvement for the community to engage in. One of the main features of this area is a trail system throughout, which was designed as a way to connect the north and the south side of Nolanville. The trail connects to the sidewalk that goes underneath the overpass and then joins another nature preserve on the south side. This area is made up of natural and native landscape features. As you will kind of see here on this slide, we're really wanting to go with more of like ornamental and native grasses, as well as decomposed granite pathways instead of concrete or anything like that. We wanted to keep the same porous and pervious surfaces like we are in the other designs. For our phasing plan for all of our proposals, within the next like 1 to 2 years, we see construction beginning on the green space project, as well as the train sensor system. We also want to start implementing the new streetscape design. And then we talked to a community member about a new commercial area on the south side of the highway that we think will have started by then. In 5 years, we see the streetscapes design being completely finished, as well as the beginning of the Smart Garden project and the Green Roof project, and then the preparation for the commercial corridor space to begin, and then the completion of the Greenway project. In the next 10 years, we think that all of our proposals will pretty much be wrapped up, and then all of the smart technologies as well will either be started or finished, including like solar panels and the smart train sensors, and then the lighting locations. And then we think the commercial corridor projects will be, if not finished, at least like almost done. And then the transportation systems in play, including like autonomous vehicles, and then the new bus routes and stops.
So as you can see, our team is working on a broad range of projects that span many, many areas of development, but we wanted to reiterate our problem statement and boil it down to the fact that we want to provide a proposal for the city to implement revitalized green spaces, promote community engagement, improve communication and connectivity, and alleviate mobility throughout the area. Below this, you can see, a rough timeline of how these things all connect together, with the streetscapes and the green roof system, leading to further advancements with train notification, smart garden, and solar panels. And ultimately, this leads to a smart and connected community that will, in the long term, lead towards an advanced greenway system, a commercial corridor, and a much more thriving Nolanville than would have previously been possible. And we want Nolanville to be known as a smart community that is both economically viable for people that are passing through and a great place to live for the people that have to live there. Thank you for your time. We really look forward to developing these solutions. We had a good time putting these proposals together, and we think that they're just very centered on the needs that Nolanville's community members need today. And we really hope that these actionable insights can be used by community officials and long-term residents of Nolanville to build a smarter and stronger Nolanville moving forward.